other mechanisms. So it doesn't mean that if it doesn't hold, we can't do anything, but just that some of the results we have might not apply. So these utility functions, where we have two components, essentially we have a value which can be anything, any function, which depends on the outcome and by type. Okay? So this doesn't have to be linear, but then we have another component, which is the money that we get, or we have to pay, right? If this is negative, it means we have to pay money to the mechanism. If this is positive, it means we receive money from the mechanism. Okay? And essentially our utility is sum of these two. And this kind of utility functions, because it's linear in money, but not necessarily, this component is not necessarily linear, so it's not linear in type, these are called quasi-linear functions. Okay? So one of these components, t here, is linear in this component. That's why it's called a quasi-linear function. So we're making this assumption, and most of mechanism design literature makes this assumption, that our utility function looks like this. So now we're not looking at just any type of utility functions, we're looking at specific structured utility functions, and specifically quasi-linear. And in that case, we're hoping to get better news, that we can actually get some results if we know that at least the utility function has this structure. Okay? So we still don't know what the types of the agents, right? We don't know their types. But if we knew that, so the only uncertainty is their type. If we knew their type, we would know the whole utility function, and we know that it's actually linear in that sense. Okay? So it can be still quite flexible. So let's start looking now at mechanisms that satisfy our social choice function, okay, that are maybe not the ones you think make sense, but let's give it a go anyway. Okay? So remember, okay, that that our social choice function, right, was to maximize the sum of values, but now we have two things. We have reports. Okay, so the agents are asked to report their preferences to the mechanism, right? So we have this picture here. Okay, so the agents are asked to report their preferences. Based on these preferences, the mechanism determines an outcome and a transfer. Of course, the main thing here is that the agents may misreport if it's in their best interest. Okay? So what we want to have is truthful reporting. Okay? So what the notation here is that I use always the hat, as common notation, to indicate the agent's report. Okay? And if that hat is absent, it means that agent's true valuation. Okay? Now, the mechanism doesn't know the true valuation, or the true preferences of the agent. It only knows what the agent chooses to tell the mechanism. Okay? So we only have the agent's reports. And the mechanism then uses that to compute our social choice function. Okay? It's a direct mechanism. So we simply set the allocation to our goal, which is maximizing social choice function. But this is based on the report. So it means that if people misreport, if the agents misreport, the social choice, the social welfare is not maximized necessarily, because it uses the wrong information to compute the allocation. And as I said before, the example, the combinatorial option, right? So one of the agents can say, for the combination of A and B, I'm reporting 1 million, and then the allocation will not maximize social choice function. The mechanism designer thinks it maximizes it, but in equilibrium it does not. But this is what we set. And then we have another thing, it's transfers, and we set it to this value here. Okay? So what does this mean? So Ti, okay, is to transfer the money that agent I receives. Okay? And we set that transfer as the sum of values of all other agents, J, not I. So so we take the sum of values, excluding our own. Okay? And that's what the mechanism pays to that agent. You see what I mean? Okay? So here, So if you forget the argmax for the moment, here we've got the sum of values of all the agents, right? So the total social welfare, and we're maximizing that, right? But here, we're not maximizing anything. We're just taking, well, we're taking the allocation here. So we're taking the optimal allocation, right? So we're taking the allocation that maximizes the social welfare. This is this little x here. So maybe we could have a, maybe it's clearer if I put here, say, an x star here, and then the x star is here. For that given allocation, we take, okay, if this allocation, this is what you said what, the value was, this is what you said the value was. We take the sum of values in that optimal allocation. We exclude the value of agent I, and that will be the transfer. Okay? Okay. So each agent receives a payment, right? Not gives a payment, receives a payment equal to the values of all other agents. Okay? Okay. So we can already start to see that if I misreport, other people, so if, you know, actually I want to maximize people's happiness, right? Because if other people are happy, I get more money as well, right? So it's in my best interest to maximize other people's happiness as well. Okay? So we'll see actually more formally why this incentivizes truthful behavior, okay? Even though it might seem like a silly mechanism. So let's have a look here. Okay? Let's have a look at an example. So going back to the example we started off. So we have this optimal allocation, so that's in this case this allocation here. Now the value, the transfers to agent 1 is what, right? So we take the optimal, the value, the total value. By the way, do you know the difference between argmax and max? It's an important kind of thing. So argmax returns the argument, right? So here I'm maximizing over all possible allocations. So argmax will return the x. If I had max, it would return the outcome of this function. so it would return the value, the sum of values, right? That's the difference between argmax and max. So the value, the total value, is already, we saw, is 190, right? So that's of the efficient allocation. So the transfer to player 1 is, okay, let's take the total value and let's remove agent 1 from the value of agent 1. Okay, and that is the transfer to agent 1. Okay. So it was 190. So if you remove agent 1 was 100, so we were left with this 90 here. Okay? So agent 1 receives 90 from the mechanism, as well as receiving item A. Okay. Agent 2 receives 100, right? As well as receiving items B and C. Okay. Now let's look at the utility of the agents. Okay. The utilities. Now remember, the utility is the value from the item they receive plus their transfer. Okay. So the utility of agent 1 is the value they receive from having A, which is 100, plus the transfer they receive, so 100 plus 90. Their utility is 190. Yeah? Yeah? And agent 2's utility is the value for getting the bundle B and C, which is 90 here, plus the transfer they receive from the mechanism, which was calculated this way. It was 100, and therefore the utility is also 190. Okay, this is important, so if you have any questions, feel free to ask. And this is the basic. basically. This is going to get more complex. Okay. So what you see here is that the transfer of player 2, for example, excludes the value of player 2. Right? That's the money it receives from the mechanism. But then it's added again, right? Because again, it gets these it gets the bundle. Okay? So the value, the sum of values, is always equal to the social welfare. Okay? In this mechanism. Okay? So that means that it is in the agent's interest to maximize the social welfare. They can misreport, obviously. So, for example, what did we say before? So, B, in the previous mechanism where we didn't have transfers, right? Agent 1 was going to report 1 million for A and B, right? Suppose that it reports 1 million for A and B. What would happen? Okay, in this mechanism. Let's see if the agent can profit by misreporting. Okay, so agent 1. Okay, so suppose agent 1 misreports his value for bundle A and B and reports 1 million. Okay, because he prefers to have bundle A and B. Yeah, he's only getting A, he prefers A and B. Okay? So let's see what happens under this mechanism. So what would be the transfers for agent 1 if it reports 1 million? Well, let's start with the outcome. What would be the outcome? The social choice outcome.
Player 1 gets A and B, player 2 gets nothing.
Yeah, okay. So the social outcome now, we have a social outcome which says A and B to player 1, nothing to player 2. Okay? Okay, that's the optimal social choice function given the reports of the agents. Yeah? Okay? So given this, what would be the transfer of agent 1 under this condition? 0. Yeah. Okay. So what would be his utility? No. This is his report, right? His utility is 180. Yeah. Plus 0 is 180. Yeah. Okay. So he's misreporting, thinking, oh, I'm going to get the bundle A and B. Okay. But his transfer changes because the allocation changes, and the transfer changes to less favorable condition. And so now his utility is 180. But if he reported truthfully, he'd get a utility of 190. Okay, obviously, just out of interest, under these circumstances, what would be the transfer for player 2? 1 million, yeah. Okay. So obviously, if they could collude and get together, right, they'd be better off in this situation. Okay, but so this mechanism is sensitive to collusion, so you can't make it too crazy. Okay, but we'll look at slightly better mechanism.
It's also very dependent on the quasi-linearity.
Yes, that's a very important dependency. Yeah. Okay. So you can see that this is actually, it's always in the interest of the agent to maximize social welfare, because essentially the sum of the transfer and their own value is the social welfare. Okay? So if they maximize the social welfare, they are better off individually without collusion. Okay? So we can make this a little bit more formal. So theta I denote I as reported type to the mechanism, and theta minus I, the reports of all other agents. Okay. We now formalize what we mean by truthfulness. Mechanism is strategy proof if for all types, right, for the true type I and the reported type hat theta, so the true type is theta I, the reported type is theta hat I, and for any, doesn't matter what the others report, it should be, you should be better off reporting truthfully, okay, than misreporting. So obviously your true value, your true utility depends on your true theta I, but the allocation and the transfers depend on the report, right? So we have here the hats here because the allocation, the social choice, the social choice function depends on the reports. The transfers depend on the reports, but obviously your true value for the item does not depend on the reports. So your utility from misreporting, which is this, should always be less than utility from reporting or equal to. Okay. So reporting truthfully should always give you greater or equal utility to misreporting. That's what strategy proofness means. Okay. That's it. An agent is always better off reporting the true types to the mechanism, and this is how it's formalized. And we have the mechanism we just saw is that the mechanism where we maximize social choice functions, the social welfare, based on the reported types, and having a transfer equal to this, the one we thought, is strategy proof. And the proof is really simple, so we can say that this is the utility of the agents, and we know that the right-hand side is the same as social welfare. Since maximize social welfare, it also maximizes utility of the agent. So this is a kind of proof sketch. Okay? So this mechanism is easy. So, but what's wrong with this mechanism, other than the fact that with collusion, the agent can make millions? What's the problem with this mechanism?
Funding the transfers?
Funding the transfers, yes. Right. So we're giving the agent money, and we're giving them the items. So we are, it's like saying, okay, here's you go to Curry's and say, here's a dishwasher, and here's another £100 as well. That's a very good cashback deal, I'd say. Okay. So obviously in practice that doesn't work. Because what we see is that the mechanism, the system itself, is running a deficit. Now if you have a very, government beneficial situation and they care about maximizing social welfare, they might be able to invest, might have incentive to invest in this kind of schemes so that the allocation becomes fair, etc., etc. But in normal circumstances, this kind of deficit from the mechanism is not acceptable. Okay. So there's another property that we are interested in, apart from maximizing social welfare, and that's called budget balance. So a budget is essentially, it refers to the money that that the agent receives from the players. Okay? And so the mechanism is weekly budget balance if it receives more money than it gives out. Okay? It's still okay, right? So you receive some money. You could do anything with it. You can burn it, right? You can get rid of it. It's fine. You can put it in your pocket. Okay. But at least it's not running a deficit. Or if it's strongly budget balanced, it doesn't receive any money and it doesn't give anything. But so on balance, it's kind of always zero. So it receives and spends equal amounts. So the total transfers received, and so the total positive transfers, the total negative transfers even out. Okay. So, but if the sum of transfers is negative, then we say it's weakly budget balanced. If it's zero, then we say it's strongly budget balanced. Okay. So that's an important problem. Now, this is not only important for the budget, say the system designer's perspective, but there's another property we like. Oh, actually, yeah, before that. Okay. So let's see. Can we fix the mechanism to reduce our budget deficit or remove it altogether? Okay. So let's apply a fix. So before, the mechanism was this part, right? So this is our transfer. So we're just going to change the transfers. We're not going to change anything else. So before we only had this part, okay? Now let's subtract a constant h from the transfers that we give to the agents, okay? So we have the same as before, the transfers as before, but h could now be 1,000,000, okay? So we're going to ask 1,000,000 from all the agents that are participating, okay? And we give them a little bit back. Okay, so we give them their 90 and their 100 pounds back. Okay, but first of all, we extract money from them. Okay, so a constant can be a constant, right? So it's a constant. The agents cannot manipulate this constant, so it does not depend on the allocation, does not depend on their reports. So it's a constant. So yeah, so if the mechanism without the constant was incentive compatible, then the mechanism with the constant is obviously still incentive compatible, right? The constant shouldn't make any difference there. Okay? We can ask the agents for 1,000,000, and then we give them back a little bit to incentivize them. So we ask them that regardless of whether they win the auction or not, just ask them the money. Just give me £1,000,000 and then we run the auction and give you back a little bit. And that, when we run the auction, they're still incentivized to be truthful. Okay? But then, what does this problem introduce?
Individual welfare is massively reduced.
Well, the individual welfare is becoming negative, and people might not actually want to participate in this game anymore. Okay? Okay? So that's not good, because you're asking people, okay, first give me 1,000,000 and then you're allowed to get a washing machine and return. That's not, people wouldn't go for that, I don't think. No matter how convincing Curry's ads are, I don't know. So there's this problem, another property we want to satisfy, and that's called individual rationality. Now, it's a bit misleading term because it has this rationality thing. The only thing it means is that you end up with positive utility at the end. That's all it means. So it's also called a participation constraint. So if you want to incentivize people to participate in the mechanism, then the value they receive from getting the items plus the transfers, which could be negative, right, should be at least equal to not participating in the mechanism at all, which usually you set the utility to that being 0. Yeah? You scale that utility to 0. Okay. So agents will never make a loss by participating in the mechanism. Loss meaning in terms of utility, right? So they may have to pay some money, but they get something in return, and that's more valuable than what they pay out. Okay. So this difference has to be positive, even if the transfers can be negative. Okay. So, okay. So let's see if we can fix that mechanism. Okay. And what we're going to do is we're going to change slightly this h function that we had before. So there's a lot of notation here, but it's the same as we had before. Okay. So this was the mechanism we had at the beginning, where we say we give the agents the social welfare except my social welfare. Yeah. And we had this constant h before, which we deducted. Now we're going to change this h. It's no longer constant, but it only depends on other people's reports. Okay? So if I'm agent I, this constant is still a constant from I's perspective because it does not depend on agent I's report. Okay? So still a constant, okay, from agent I's perspective. So if you have an agent J, we have to do the same thing. We remove agent J's report from the H. Okay? So we do that for each agent. We have this function now, which depends on all other people's times. Okay? So that's indicated by -I. Okay? minus I means everyone except agent I. We have a function which depends on everything except the reported type of everyone except agent I's report. So essentially, because it does not depend on what agent I reported, it's still a constant for agent I's perspective. Right? So we can have a lot of different functions now here as H. And as long as it does not depend on agent I's report, it's still strategy proof. Okay? We can, whether it satisfies, we can set this to 0, for example. Right? Whether it satisfies budget balance and individual rationality is another issue. Okay? So we need to find an HI that satisfies budget balance and satisfies individual rationality. Okay? Now, this kind of class of mechanisms are called Groves mechanisms, after Pygold Groves. Okay? So we have this whole class of mechanisms now, and they're all incentive compatible, or strategy proof. Okay? They're also all efficient because we are maximizing the social welfare. That's the same as being efficient. And it does assume quasi-linear preferences. Okay? So we have this whole class. Now, the key thing is to find a mechanism that maximizes, that satisfies this budget balance constraint. So H can't be, say 0, right? It has to be positive. Okay. Right. In most cases, anyway, on average. And it has to satisfy individual rationality as well. So, okay. So I think I'm running a bit out of time. So I'll keep that for Thursday. Okay? That's a big surprise. So how do we do that? Okay. So we'll continue on Thursday. We'll start Thursday also looking at certain examples. We'll do them together in the class, so we'll do a much more interactive class on Thursday, and then just go through a number of examples. Okay. Good.